Welcome, everyone. My name is Jamie Knowles. I'm Director of Product for EL Studio. I'm joined here by Tim, who's our lead solution architect. Today, we're going to walk through how EL Studio helps organizations design and deliver a modern data platform. We're going to use the term data platform rather than data warehouse. It's much more than a data warehouse. This is one that connects our business understanding to our technical implementation. We're going to talk through our approach, and we're going to show you some demos of how the tool is going to make it happen.
Yeah, and I'm really looking forward to seeing how ER Studio Enterprise is really the go-to solution for this data product design strategy and story.
Beautiful. Yeah, we're going to take you through a story. So starting off with how the business and its domains work to then define the information of the organization, define its data products, and then how we realize those in a medallion style data warehouse.
I was just going to say, before we get into the modeling, can we talk a little bit about what a modern data platform is? What are we really trying to achieve there, Jamie?
Yeah, we've got some bullets on the screen here. So we've got 5 mission points. The main mission is getting together all this diverse information around the organization. We want to bring it all together into a single source of the truth. We want excellent quality. We want to understand the sort of the lineage and the journeys that the data takes through there. Self-service analytics and AI. So we want everybody in the organization to be aware of what data is available to them and to be able to get access to that data. We want the subject matter experts of the different domains to be able to create and curate the data that the rest of the organization demands. We need an architecture that is scalable and flexible. So we're going to use the latest technologies, hybrid and cloud native designs, but we really need a good architecture to make it grow, to allow us to grow and make it manageable. The old world was very difficult to scale, difficult to manage, difficult to govern. We ended up with swamps. So we need a good, flexible architecture. We need a really accelerated process. So we want model-driven automation. We want code generation. Okay, so we want to accelerate that process. And I think that the key point to a modern data platform is this new approach. So understanding our data as a product. I think in the past, data has been a second-class citizen. What we want to be able to do is treat data as a valuable business asset. We want to catalog it, manage it, maintain it, govern it, and make sure that the products that we're providing to the rest of the organization have value to them and they're of good quality. Okay, so that's why modeling is really important. This is the glue that's going to drive everything. So good architecture, good design. Okay, so I'm going to explain to you the 2 approaches we take in design and architecture nowadays. So on the screen here, you see a little process. When we're building or creating anything, we go through this sort of process. We take some requirements, an architect comes along and listens to those requirements and creates this sort of sketch of the assets. In this case, a logical data model, all in business language. Okay, and there's various iterations on that. So the architect will work with the subject matter experts to understand the requirements, the data assets, and eventually they'll get that logical model right. We'll have some sort of approval gate. And from that, we'll then generate a physical model. This is the sort of the wiring diagram, the blueprints of that data assets that's faithful to the technology that's going to implement it. And again, we'll have various iterations on that until we've got the design right, and then another approval gate. And then eventually we'll then generate the code. And ER Studio really sort of takes you through this process in a controlled and managed process. And then the opposite is also true, and Tim's going to show you this in a moment. So understanding existing assets, so we can reverse engineer them, create physical models. From the physical model, create a logical model in business language. And that logical model should be a really sort of easy to understand, business-friendly view of any data assets. It's faithful to the information. Everybody should be able to understand what information is in that asset. So the logical model is really important. Now, the key thing in an enterprise data architecture program is the notion of reusable architectural patterns. We don't want to design everything from scratch in isolation. We want to use common reusable patterns. And we create the notion of an enterprise model or domain models or some sort of common model. So as we're creating each design, each logical model, we'll go through from the requirements and see if there's any existing patterns that we can reuse. So in this case here, so the requirements talk about a thing called client. And what we're going to use is this enterprise data model. So you can see here, there's two levels to it, a very high level conceptual model, and then a more detailed logical model, which has got a lot more information in it about how we identify things and standardized attributes of these different concepts. And you can see it's broken down with these sort of gold lines to show the different, in the past we used to call them subject areas. Nowadays we call them domains, the domains of the organization, sales and marketing, product. Okay, so in our little design story here, we said, okay, so the requirements talk about a thing called client. Is there anything like client in our enterprise model? Yes, we've got the notion of customer. And it's even telling us that there's different subtypes of customer. Ooh, we've got a B2B customer and a B2C customer. Which one more aligns with our requirements? Well, in this case, it looks very much like it was a B2C customer, which is a different concept to our B2B customer. So going back to our model here, we then reuse those existing entities in our new logical model, in our design. Okay, so that's the sort of process that we're going to go through.
So, Jamie, there that enterprise logical data model really becomes kind of a master template, right, for these reusable architectural patterns that really translate into your data products later. Then,
yeah, absolutely. This is kind of the framework for everything that we do, and this is a really important aspect. So, one, yep, we're going to document all of our data assets against this. So as we were saying earlier, that sort of harmonization process, we want to reverse engineer a particular system, understand the data in that system, and see how it maps to this framework. Sort of, this is our comparing eggs with eggs sort of framework. It's a great way of documenting the organization. The other thing we're going to use it for, and again, Tim, you're going to take us through this, is then how do we design new assets in our data platform? It's then got loads of other benefits as well. So, for instance, AI's BI tools that allow you to sort of run natural language queries on your data. We want to be able to provide knowledge to those AI components, those semantic layers to them. And then this sort of business model provides that sort of semantic model of the organization. So it's tremendously important. So earlier on, we talked about data as a product. And again, we were talking about splitting the organization down into domains. So we can see here on the screen, we've got the vertical columns, the different domains. These are accounts, product management, sales, HR, those sorts of business units. Each business unit will come up with its framework of what information are we interested in. I'm going to show you that in a moment. And we might define the policies and the rules that the business wants to apply to that information. Okay, and some organizations might use a business glossary to define that framework of information and policies and rules. We're going to use a slightly different approach where we're working from that enterprise logical model. Tools like Calibra use that approach in their guided data stewardship approach. ER Studio also allows you to generate a business glossary from these sort of models. So either is fine. So right at the top there, yeah, we've got our sort of framework for how the domains understand their information. And then each domain will then start to think about what data products does the rest of the organization want from us. So the HR department might say, hey, we want a list of departments or a list of employees, or, and Tim's going to take us through this later, how sort of commission payments are paid to salespeople. We might want a report of that. And the process that we're going to go through for building these products is we define a contract. So we're really taking these products seriously. So the subject matter experts will define, yeah, we want a product. Here's the requirements for the products. And then we go through the process of defining the contracts. And the contract's got two parts. What information are we going to get in this data product? And this is where that logical data model comes in. And again, Tim's going to take you through that process. And then the other part of the contracts are the terms and conditions for usage of that product. Is the sensitive data in there? What's the entitlement for it? There might be a retention period, all these sorts of rules around it. So the contract's really, really important. And once the contract's been defined.
So I just had a question there. So as we are understanding domains there, what's the correlation between those domains, these business level domains, and the logical modeling we might do?
Yeah, and I'm going to come on to that in a moment. I'm going to sort of take you through an example of how we might build out and understand the domains. But it's an important question. I think that the data as a product approach is really about sort of decentralization, allowing the business teams, the teams of subject matter experts to really sort of manage their own data and define these data products and then the governance around those data products. So it's a really important task to define what those domains are and what information is the concern of each domain. But I'm going to take you through that in a moment. But in the process, each domain is going to build out its data products. And then eventually those data products will be realized as some sort of physical asset. It might be tables in the data warehouse, star schemas, which might have then BI reports run against them. There might be APIs with JSON schemas in there, or multiple physical realizations of those data products. But all of the physical realizations will be governed by the same contracts, have the same information with the same rules. Okay, so that's a really important part of the story there. So is this sort of process you can see on the screen. So step one is what I'm going to take you through next. So defining the information of the organization, defining the information, the concerns of the domains. And this is going to be a sort of a joint effort by the data architects and the subject matter experts. Only the subject matter experts have got that knowledge of the business. The data architects are going to help them realize that into these logical models. Okay, and from that we can then generate business glossaries, etc. Step two is cataloging the source data assets. So in our new data platform, where are we going to get all this data from? We've got a rough idea of the sort of information that we want. As we define our data products, those requirements will harden up. We can kind of run in parallel, cataloging the source assets and defining the data products. Defining data products defines the requirements for the platform as a whole. But we really want to know very quickly where we're going to get the data from. So ideally, we have a full catalog of all of our different business systems, maybe data in the data lake as well, all the possible data sources that we could use to feed our modern data platform. So it's kind of two questions we want to ask. One is, what data assets have we got? And what does it mean? And the what does it mean is answered by that mapping back to the information of the organization, these models we're going to produce. So once we've got our catalog, we can then define our data products and those contracts. And again, the subject matter experts are the people that are going to define what products we're going to provide and the basic requirements. And the data architects will facilitate that design journey to create the contract. And once we've got the contracts approved, then we can start building out those data products, deciding what tables, what assets will be in the data warehouse. We can build the pipelines to those different tables in the warehouse. We can test them, and then we're ready to consume them. So that's the basic process that we're going to go through. Next thing I want to talk through is how do we define the information of the organization. So let's go and have a look at ER Studio. Here it is. So this is a data modeling tool. This is a logical data model. So the white boxes on the screen here are what we call entities or concepts. And those concepts or entities have attributes. So we can see here employee above the line. How do we identify an employee? Through its employee number. And then these are all the different standardized attributes we've got. So what we're looking at on the screen is a model of one particular domain. Over on the left-hand side, you can see that I've got a number of different domains. I've got accounting, I've got human resources, I've got product management, I've got sales. And you can see here in the sales domain, this is all the information that sales is interested in. Sales is interested in customers over on the right. We're interested in orders and order lines. We're interested in products that are sold. We're also interested in the commission payments made to employees, which are salespeople. Okay, so this is all the information that our sales domain cares about. Maybe later on, some of these will appear in different data products. An important thing about this approach is the notion of ownership. So some domains will own certain pieces of information. So here, sales owns orders and customers and commission payments, but HR owns the notion of an employee. Product management owns the notion of a product. And this is really important in our overarching architecture for our data platform. So across those different domains that we were looking at. So let's go back to this slide here. So all these different data products, we need to ensure some sort of consistency. And this is a question that I think every every one of you should really be asking is, how important is consistency to us? It might be that you say, right, well, it doesn't matter at all. The notion of customer could be different across every data product. It could be different across every different domain. Or you might say, okay, we want consistency across all of our products within a domain. You might say, well, the notion of customer needs to be consistent across all data products across all domains. So this enterprise domain level data model that we've got on the screen here really allows us to define those standardized components. Here we've got one single standardized definition of what is an employee. How do we identify what's the business key for an employee, the standard attributes of an employee, and then every domain can then reuse that. And Tim will show you, as we're designing our data products, how we include that sort of standardization. Okay. The domain teams, we've now got a framework in which we can attach all of our classifications and policies. Each of these entities here, we could go along and attach various pieces of information. Ooh, employee, that's personal data, highly sensitive data. So we can classify each of these entities and attributes. We could apply different policies and rules. We could also use Team Server to generate a business glossary from it. So this is our web product Team Server. We're looking at the enterprise data model here. We've got all those different domains that we were just looking at. We can go into each of them. We can see all of our different entities here. From this, we could generate business glossaries, one or all business glossaries. I might say, great, harvest the terms from the entirety of our enterprise model and create one single glossary. Or I could go down into different domains and for each domain harvest an individual glossary. And ER Studio will do that and connect it back to that enterprise model. But it gives us a lot of flexibility. All right, so we've got our framework. Step 2, Tim, this is where we're going to start understanding our data assets, our data sources that are going to feed our data warehouse. So as I said, we've got 2 steps. One, that catalog of assets themselves, and then 2, understand the meaning of each of those.
Thanks for going through all that, Jamie. And it's good to see the correlation between domains. You know, we used to call them subject areas back in the day, and how those relate to really submodels in your enterprise logical data model. But one of the first things I think organizations need to get kind of their grips on is their existing data sources, right? If you're going to have an enterprise logical data model and you're going to understand what your key concepts are and tie all that in as your ELDM as a hub, how do you figure out what your existing data sources are, what their importance is to the organization? So I'm going to take you through that very quickly. I've got a model open here, and I'm going to do a reverse engineer process, which is one of the key features within ER Studio Data Architect. I might mention we're looking at ER Studio Data Architect 20.9 here. You see we have a reverse engineering wizard come up. We use wizards very extensively through the tool to make it easy and intuitive to use. You see I have a number of ways to connect here. I'm going to work with SQL Server here today and use a standard SA connection for it. And here on my database list, we'll take this little journey here on this TRNG-DB and just, like I said, create some knowledge about it. I'll take the standard options here today. We do have plenty of videos on our resource center that delves into these individual features and all their various uses. But for today, I want to show you that creating knowledge story. So I'm going to kind of click through, take the standard options here, and I'm going to hit finish.
There's a lot of scary looking table names there with sort of abbreviations like EMP. It all looks quite scary. I guess, is there anything that ER Studio can do to help us give business meaning to those things?
Absolutely, absolutely. And we call those naming standard templates. And you can see as I've done this reverse engineer here, and maybe I could zoom in to fit model here so everybody can get a great view. If I look, we've received both a logical and a physical model now, and I'll zoom that in to fit. They look largely the same. And as you do say, Jamie, there's a lot of scary names for things. What's VCT days down here? You know, there isn't some here that like maybe a business analyst or data engineers, any kind of end user could understand at a business level what this data means, you know, how important it is to the organization. So we have a facility within data architect called a naming standards template. So you'll find those under the data dictionary tab. There's naming standards templates there, and I'm gonna go ahead and include one here that I have already made, just importing that locally. I call it corporate naming standards templates. And to show you what these do at the logical and physical level, for those associated objects, you can pick a case statement, a prefix, or suffix. Do that at the physical level, as I mentioned. But then you have that all-important mapping tab, Jamie. You have that tab that's showing you that translation, that lexicon from what might be those shorted, abbreviated names for things at your site to something that makes more sense at a business level. So if I say OK there and go ahead on my data model and apply that template to my logical model using the other half of the naming standards process, which is the naming standards utility, I'll select that with a right click select. On my options tab here, I'm going to choose that corporate standard template. Notice it's a drag down, and you can have many naming standards templates, different platforms, different geographical areas, business units, that kind of stuff. Have a few, sure. Don't have many, becomes something else you have to track. And on my output tab, I'm going to go ahead, shortcut here. I'm going to apply that template to all my logical entities and attributes. Hit our little run translation button so you can get a quick sanity check on the names it's going to change here. And I'm going to say, OK.
Oh, that's much easier to understand, isn't it? Yeah, I like that.
Much easier to understand. And now I think, everybody can start to understand what this logical model is about. And I might mention with the Studio, our logical models are platform agnostic here. So I could generate, even though this physical model came in from SQL Server, I could now generate this into Snowflake, Oracle, or any other of the legion of our supported platforms. But we have made a lot of business information, and I won't go through all the iterative steps a modeler might take here, but I will show you that once you introduce this model into the repository by going into the repository, logging in, and adding the diagram, then on your next visit, you can, in the data architect, you can go ahead and get that diagram, and I've done that in this tab. And this is that same model. You notice that platform agnosticity. We've able to port this particular schema into many different platforms. You might say, hey, that doesn't come up too much. But hey, think about your data product creation story where you have maybe a physical model for your Snowflake Kimball enterprise data warehouse, but then you have individual data products that might be JSON or Kafka streams or external views, something like that. All those different physicalities could be separated into different physical models within the same design. You don't have to separate it out. And that logical model platform agnosticity really, really comes in key on that data product design story that I'll talk about next.
I see you've added lots of really useful information in here as well. I can see there's colored boxes grouping areas together sort of into similar sort of groups of entities. I can see that you've got all sorts of sort of extra properties and classifications of some of this data. So that's a really nice job of documenting this. I guess you can add in things like descriptions and stuff as well.
Title blocks and descriptions, these nice little colored boxes, as I told you, we call those business data objects. You'll find those right in the tree. And a lot of people use those to encapsulate on large models, those areas that might actually equate over to a domain or a subject area. So yes, we've used attachments, compliance mapping, gone through that iterative process a modeler or an architect does to really kind of flesh this out. One of the things that I wanted to show you in here is once we have a repository diagram, and you can always tell that once you introduce a model into the repository, you get all these padlocks. That means that's telling you this is a repository cognizant model. And now, since it is repository cognizant, on this model, I can go into something, say, like the employee entity here. And we have all these different facets or tabs of information that we can provide, notes, definitions, all of that kind of stuff. But notice also we have a glossary tab now. This glossary tab is really showing you, and it's easier to see if I hit add term, that the term employee both employee new and employee, these terms have been associated with this employee entity. So it's really tying it in, right? You see how this is the inroad into tying this into your data governance. As a matter of fact, if I jump over into, as Jamie showed earlier, our web portal, I can go straight in and say, let's take a look at that model right here in ER Studio. Sorry, I got a little cross-eyed there, and there it is. And you could come right in. So this is a live URL. You can send that to your teammates. But gone are the days where you print these out on plotters. I do happen to remember those. I can come into this same object just as I showed you in Data Architect, although now we're using an unlimited use web license, and see the definition, the attributes, everything about it, even where it's used. And notice it's showing us the where used
so they're all
qualities
the physical models that are instantiating or realizing that this particular logical model. So
Correct.
one of those is the database that you just reverse engineered. That's really cool. So it's really nicely documented. So the next question I've got is, so we've got this table called EMP that we found in a database. You've said it's employee. I mean, how do we sort of compare eggs with eggs? I now want to see that enterprise model where we define that common definition of employee. Can we connect it to that?
You absolutely do, and you can see it here with universal mapping. So there's a lot of different journeys you can take within the product. Let's go back into Data Architect for a second. I can show that at the Data Architect level at the where used. And you can see on where used here that there is a universal map, which means we've used this ELDM, the Enterprise Logical Data Model, the logical employee. There is linkage there. I can show that graphically and visually in Team Server as well. It's right here. So if I want to see, let's go up to this Enterprise Logical Model for a second and take a look at its definitions here, and take a look at employee here. Hopefully I'm not clicking around too much to answer your question, but since I'm not my Enterprise Logical Data Model here on employee, I can show the related objects. And I think that was the crux of your question there, and I could see all the different models there. I could get it in list form as well, but there it is. And
that's a really powerful question. So if I'm ever looking for employee data, I can go to my enterprise logical model and find that standard definition of an employee, or maybe different subtypes of an employee. And then this is going to show me exactly where is that data in terms of all of my different data assets, all my different models.
Absolutely. Right? Another way to do that, and not to jump ahead, but it is in context. You can go right in Team Server Core to terms and look up that employee term, right? I showed you that linkage in Data Architect. So I can look at that employee term at Human Resources, and then I can see its related objects there too. So we got that term linkage. And this is also part, and I'll show this in the data product creation story too, but there it is from that business object, that definition of what an employee is to our organization. There it is, linked to our HR database, right in the logical model and the different physical models we have.
So that's the magic moment, isn't it? So any business person can browse through the business glossary here, looking at related terms, find a particular term which represents a piece of information that they're looking for, and say, right, where is this? Does it exist in the data warehouse? Does it exist in source data assets? And you've shown here that HR database that you've reversed engineered and documented and cataloged. So we've now got a really good data catalog, haven't we? We know exactly where.
Yes, we do.
Beautiful. That's great. All right. So now the business knows where information is, what it has. We can start thinking about what access the rest of the organization needs to that information. How do we translate that into data products?
So there's a couple ways looking at the data product creation story, and the one I most like in ER Studio is this idea of our integration with leading data catalog and data governance applications, and one of the chief among them are Calibra and Purview. And I'll show this to you, Jamie, in Purview here today. So if I go into Purview here, and I've logged in already to save us some time, and I'm in catalog management under data products, And this is where you can actually storefront within Purview the idea of, hey, I need a new data product that's commissioned. And so there's been some work here, but this is the story we're telling today. How do you get there? How do you facilitate the creation, really visualize and then curate these data products? So in Purview, you would enter this. There's a really neat feature within Data Architect called our AI Model Builder. So I'll go ahead and copy that text out here, and you can see that we have just a blank request here. So really the journey here would be then to go into Data Architect, and I'll close some of this out here from our previous discussion here. And I'll go into model, or just an empty model here. Under tools, you'll find this new feature, and what you can do here is use that text that you get from Purview and hit the generate button and let it give you a very good first pass at creating that logical model right from that business level, like a business analyst or a BI developer or something like that has come in and asked for this data product. So I'm going to hit the generate button here, and as that percolates, I'm going to show you a couple other things.
So that's sent that set requirements off to the IDEA server. The IDEA server's now got a GPT-5 instance behind the scenes that's now processing that and generating for us a logical data model. I guess the requirements could have come in all sorts of forms in Purview. It could have been a list of business terms. I guess we could have gone through the process that you just showed, Tim, where we, from that business term, said, hey, do any of these terms exist in our enterprise model? And we could have sort of copied things from our enterprise model manually down into our new design for our data products. But what you're doing here is you're getting the AI to give you that first cut model. For our listeners here, just to let you know, in our roadmap, we've got an enterprise version of this AI model builder coming out, which will actually go through that process for you. So what it's going to do here is create the model in isolation. But what it's going to do in the future is actually look up any entities that it wants to create against the enterprise model and look for the most appropriate entities and copy those into your first cut design of your data products. Does that sound about right then, Tim?
Absolutely, absolutely, and of course there are different paths you could take. I could start with a new model, use our compare and merge feature to bring in those templates from our ELDM to create a your first pass logical, in this case commission data product logical model. I just find this AI model builder to give us such a quick start on things. I really love using it here. So now we have our data product back, and what we've got back here is that, as I showed was talking about, Jamie, kind of a first pass logical model, and as you said, roadmap would be tying that into your ELDM and your overall enterprise data strategy. But right now it's given us that first pass. You can look at what it's done for us. It's come up with employee and product, an order, and then you could take the next steps in the data product creation story, where you could add it to your repository, as I've done here. You can see this is all part. Now we have our business friendly names after applying a naming standards template to it. And you can see if I click into the employee entity, for example, it's all linked in to our ELDM there from this data product, this commission data product. It's all part of our enterprise data program. There's probably the employee term associated with it. And so now you have really a great first pass at a data product that is you store back into your repository. And then once you have it in the repository, it can be sent back over to your Microsoft Purview. And if I look at data products here, I can see that this commission data product has indeed been sent now to fulfill this storefront request in Purview. And you can see that the data assets are there, that we have an ER Studio logical data model. I could click into that and get a backlink. You could see that I could add a glossary term over to it, those kinds of things. So that's really all part of data product creation story, and to take it just a step further in Team Server, I can then show if I go to terms here and I show that employee term again, or I could look up for products or orders here. Here on employee, I could show the related objects here, and that commission data product is right here on the screen. You can see there's that logical model. That's where you would kind of work that with the business analyst that requested this data product, and say yes, that's the logical model. That's really the, as you would say, Jamie, the contract I'm looking for. And then the modeler could take off and say, hey, I want to generate a physical model for it in, say, JSON or one of our other platforms. So that's really part of that. All that linkage, that curation, and facilitation of the creation of that data product right there, our commission data product.
Nice. Okay, so you've defined a logical model. In this case, you use the AI model builder to create that logical model. You've published that logical model back to Purview, so that anybody can then see the content of the data products in Purview. It can be browsed from business terms in Purview or in ER Studio. Okay, so I guess the next part of the story then is realizing that data product. So let's go back to ER Studio again. Okay, so this is our enterprise logical model we were talking about. We can see those entities that Tim put into his logical model: employee, commission payment, and order. And Tim sent that to me, which is just here on my screen. Okay, so that's the logical model that Tim just created. And what I've got to do now is then realize this in our data warehouse. So the process that I'm going to go through is this. Looking at the screen, we can see that we've got our enterprise logical model, which kind of gives us the framework for everything that we're going to do. We've got our source asset that Tim had reverse engineered and attached to that enterprise logical model. We've created over on the right hand side that logical model representing the contract. So what I've got to try and do now is then realize this. And probably what I'm going to do is create a number of assets in our data warehouse. I'm going to create some star schemas. I'm going to create some tables in the silver layer, and then I'm going to create some tables in our bronze staging area, which is going to accept the data from Tim's system that he reversed engineered. And you'll notice that across the top, the blue section is the same logical model for all these different layers. Semantically, they're all the same, just different realizations. So at the bottom, Tim's system had got different tables there. We saw EMP, for instance, in the silver layer. Okay, that's going to be pretty faithful to our enterprise logical model. We want our silver layer to be driven by the design of the business, that harmonization, that architecture that we were talking about earlier on. So that single source of the truth. I want one single table in my silver layer that's going to contain all of my customer data. I might have many different source data assets over on the left that contains customer information that I'm going to combine together into that one single customer table. But I want that harmonized view. And then from my silver layer, I'm then going to create potentially multiple star schemas that then holds that data again. Okay, but they've all got the same logical model. Let's go over into ER Studio and see how we go through that process. In my enterprise data warehouse here, you can see I'm in the model for my warehouse. I'm reusing that same enterprise logical model. So different layers. We could start off in this case with a source system. Okay, I've reverse engineered the source system here into a physical model. Okay, and it's all nicely documented. I can then start to understand the tables that I'm going to create in my bronze layer. Okay, and I've got different submodels that represent all the different systems. So there's my salary DB set of tables in my bronze layer. So what I've done, I've used ER Studio to make a copy of those tables. I've ignored all the foreign key constraints. I've just got a set of tables in here. I could maybe add in columns here to set the sort of historical properties, so I can take multiple copies of this salary DB system over time. Okay, so that's my bronze layer, and I've got a physical model, and it's mapped up to my logical model. I can do the same thing for the silver layer. So if I go to my logical model, I've copied entities from the different data products into this one logical model for my silver layer. So there's employee, commission payments, and order. We've got extra stuff in here that's not going to satisfy Tim's data products, but the silver layer is going to support multiple data products. But I can create a logical model of my silver layer.
But the fact that you've mapped all this in and it's dependent on that ELDM, that master template we have, we're going to carry through that consistency, aren't we?
Exactly. Yeah. That's it. And all of this is coming from that enterprise logical model. So we're using the business's definitions of these pieces of information. So here for employee, we've got the business's definition of what its business key is. We can use the employee number. And over time, all the different source systems, we've got to correlate business keys in those source systems with the business keys in our silver layer. But this is going to help us with that process, help us really understand these different systems and what are the keys. So from this logical model for our silver layer, I can then get EL Studio to then create a physical model for this. And I can choose whatever platform it is. In this case, I'm using Databricks. Okay, so from that logical model, I've asked EL Studio to create, and then as I change it, update this physical model for our Databricks database holding our silver layer. Okay. For the gold layer, same sort of thing. So I've got the same logical model. I've got commission payment, order, and employee, and I'm now going to create a star schema from that. So again, a new physical model. Again, this one's also held in Databricks. You can see at the bottom of the screen, but I've refactored those logical third normal form entities into a star schema. So I've taken commission payment as the central fact table, and all the other data I've added as different dimensions. Now, Tim was showing the AI tools in EL Studio. Next year, we're going to be providing sort of really nice tools to do that refactoring process automatically. You can literally tell the AI, take this logical model, third normal form that I've copied from my data products or my enterprise logical model, and create me a star schema from it. Okay, the tool will do it automatically. So I've got my physical model. I can now, from EL Studio, simply generate my DDL code, which will create these different databases. So what I've done now is I've created multiple physical models for each layer of my warehouse. I've got bronze, okay, with my staging tables. I've got silver with those harmonized standard common tables, single source of the truth. And then I've got my gold layer of the warehouse with my star schemas. The next thing we can do is start to understand data lineage or flow through the warehouse. And I've got a little data lineage tab here, and I can create these different flow models. So you can see here, for instance, silver to gold. So there's my silver tables, and I'm showing at a very high level the flow from those silver tables to the different star schema tables. Okay. And sometime next year, we're going to be generating code out to tools like DBT Labs. Okay, so that was a real sort of high-level whistle-stop tour as to how we take Tim's logical model for his data products. We've taken the enterprise logical model. We've taken the documentation of a source data asset, and we've used that to design the different layers of our data warehouse and the pipelines in between. Let's start wrapping up. We're running low on time. Okay, so we've got a process now where we can build our data platform, design our data warehouse. Architecture has been really important throughout. We've gone through a really controlled design process, starting with requirements, making sure we understand those requirements and we get approval of those requirements into the definition of a data product. Against that, we've got our understanding of the different domains, the business model, that enterprise logical model, those domain level logical models, which we can then use to provide a governance framework. So we've got improved governance. We've been through that process defining the data products. Our products are now well defined, reusable. We've got standardization built in throughout. Our process that we've used is scalable. One of the problems that we had with traditional data warehouses was things got unmanageable pretty quickly, ungovernable. We ended up with a swamp. Every time somebody wanted some data in there, we just pull in data from different source assets, and we might have sort of copies of data. We weren't thinking about that sort of harmonization, that silver layer that we've got in our Medallion architecture. But our platform that we've built here has been well architected. It's driven by definitions provided by the business. No more swamps.
I was just going to add there that, I think through this presentation, and I hope you all get some value out of that, we've really showed that linkage really from all the way from your business requirements, all the way down through your enterprise data strategy, including your enterprise data warehousing philosophy, all the way to that data product, and how it all ties together to ensure that consistency, that curation, and just that governance of your metadata. So I hope you all have enjoyed this.
Yeah, and I think one other point that we didn't make is that it's all well documented. Anybody can go to Team Server and browse, starting from a business term, starting from an enterprise model, looking for data, looking for are there any existing data products? If there's not, then great. Does the data already exist in the data warehouse? Yes, it does. Great. Or no, does it exist at source? We've got all that information to hand, both in EL Studio, and as Tim showed, we've synchronized that with your data governance tool like Purview or Calibra.